All right, guys, how we doing today? Today, we're gonna talk about skewness, okay? So if we have some data, either box plots, histograms, or dot plots, we're gonna talk about what happens or what I mean when I say something's left skew, symmetrical, or right skew. It's not too complicated. It's more of just visual stuff, not really too much mathy, so you may like it. So let's just jump right into it. Now, I want you guys to write this down first. Left skew, left tail, or tail to the left. Symmetrical, no tail. For right skew, I want you guys to put right tail or a tail to the right. And you'll see what I mean in a second, but just copy that down. So let's talk about left skew first. So for left skew, we're gonna talk about, obviously, we're gonna have our box plots, we're gonna have our histogram, and then we're going to have our dot plots. For a box and whisker plot, okay? Now again, we're just going for looks here. I'm not gonna make it too fancy, right? But I'm gonna do a box and whisker plot. I'm not really too big on what's going on here. What do you notice about this box and whisker plot I just drew? Well, it looks like all my data is clumped up on the right, and I have this long left tail. That's what it means to be left skew, okay? For a histogram, usually histograms got a nice little like curve to it. So again, I'm gonna have all my data on the right with a big left tail. And look at that, my data's to the right, there's all this clump, and then it tails off to the left skew. For a dot plot, again, I'm not putting any numbers on here because you know what? I'm not gonna make it more complicated than it needs to be, because in reality, all you need to know is for left skew or a tail left, it means all my data is gonna be to the right, and then there's gonna be a little tail of data going to the left. So look at left tail, left tail, left tail, okay? That is left skew. For symmetrical, no tail. Well, when we go through these, I'm going to do things that really don't tail off, right? Everything's gonna be kind of like nicely in the middle, just evenly distributed. So if I had a box plot, both whiskers are relatively the same size. In my histogram, notice the hill is pretty much in the middle. It's not bigger, the tail's not bigger left or right, it's just kind of pretty much in the middle. There's really no big tail. It's kind of even. For a dot plot, let me just put a bunch of dots. Again, I could make this fancier and put a bunch of numbers here, but I'm not. Look at that. I got a nice little chunk of data. I got maybe just a couple little dots going off to the sides. It's not leaning one way or the other. All data's pretty in the middle, evenly distributed. And that's really about it, guys. For right skew, right tail. Well, if you guys are predicting the future, it means I'm gonna put my data clump on the left, and small whisker going to the left, but I want a large whisker going to the right. If I have my histogram, well, I'm gonna put my big bell curve, my big chunk of data to the left, and I'm gonna tail to the right. For a dot plot, I'm gonna put majority of my data to the left, and then I'll put a little bit to the right. Put a couple more dots here. That's it, guys. So left skew, tail left, tail left, tail left. Symmetrical, pretty much evenly distributed. Really no tail, no tail, no tail. For right skew, right tail, right tail, right tail. And that's it, guys. That's as simple as it gets. So hopefully it's a good visual for you. Graphic when you guys look at your own box plots, histograms, and dot plots, and have some fun. So good luck, have a great day, stay healthy, stay safe, goodbye.